All right. Welcome back, everyone, to the Manny Bernabe Show. Good to have you here. Today, we're going to be talking about some cool trends that we're going to be looking out for in the AI and machine learning space in 2020. So we have a list of 4 cool things that we're going to be watching. We'll talk about why they're important and why we're excited about developments in those spaces. So without further delay, let's jump right in. So trend number 4 for me is better machine learning tooling. So historically, one of the toughest parts of standing up a data science team or function has been figuring out the infrastructure situation. So where as a team are you going to be storing your data? What is going to be your compute situation? Are you all going to be using your local machines, or are you going to be leveraging some on-site server? If so, how are you tapping that server so you're not getting in the way? How are you setting up the server to be configured in a way that's most optimal for your team? Another thing you think about is how are you going to collaborate with other data scientists? How are you going to share code? How are you going to ensure reproducibility within your team as you're sharing scripts and programs? Those are all challenging questions, and generally there haven't been a lot of great answers or solutions as you were sitting down and trying to construct that infrastructure. My experience has been that what you'll find is a lot of legacy computer programming themed solutions that you might use for data science, but they're never really the right fit. They tend to be somewhat clunky to install. They tend to be expensive. They tend to be hard to use. You usually need a lot of DevOps folks to maintain them and to support them. It's generally been a kind of a big hassle. Recently, however, I've seen a lot of great products and services that are making this a lot easier. So I'm thinking of vendors like Databricks, vendors like Domino, and also some of the cloud providers like AWS's SageMaker. These are solutions to solve that infrastructure problem, to make it easier for data scientists to collaborate, that have really matured in the last several years and are custom built for the data science workflow and the needs of a machine learning engineer and a data scientist. So I know that as little as 3 years ago, I was struggling with these questions when I was trying to stand up a data science team. Today, I would look to vendors like Databricks and Domino's and some other options and just use that out of the box and save myself a lot of trouble, and also have a better user experience for my data scientists. So really great to see that trend. The more, the easier that we can make it for data science teams to focus on just data science and not have to worry about infrastructure storage and deployment stuff, the better for everybody, for the users, for the data scientists, for the rest of the team. So really encouraged to see this area blossom, and definitely will be watching this area for more developments and more innovations. So that's number 4, better tooling for machine learning and data science. All right, trend number 3 for me is the ongoing cloud wars. So cloud infrastructure has become a big deal for data scientists and machine learning engineers. We'll leverage cloud platform to do a couple of things: to store large amounts of data. If you need to park 100,000 PDFs, you do not want to be doing that on your local machine. It's much easier to set up some sort of blob storage on AWS or GCP and push the data there. And it's also backed up. We'll also leverage cloud services to spin up large compute clusters. So historically, a lot of data science has been done on local machines. That's okay for certain tasks, but when you get into the realms of big data and fairly complicated machine learning algorithms, you need something that's a bit beefier and something that's specifically customized to do data science and machine learning. And you can access that on the cloud. You can set up a virtual machine that is the equivalent of 10 of your laptops. It can be containerized, and it could just be meant to do one particular type of machine learning algorithm and just be optimized for that. If you want specialized hardware like GPUs, graphics processing units, or even tensor processing units, TPUs, you can now spin that up in a virtual environment and have access to that hardware from the convenience of your local machine. So from a data science perspective, this is a great tool and a great option to leverage, and you don't have to be eating up all of your computer's resources to do those jobs. You can just spin up that VM. You can have that job run overnight, and just pick it up in the morning, and not be worried about whether or not the machine is going to go down or you need to use your machine for something else. So that's another great way to leverage cloud platform. The other manner in which we'll leverage cloud platforms is in deploying machine learning services to production environments. So the job of a data scientist isn't going to end until we're able to output predictions to some end customer or some end application in a very efficient and consistent way. So we'll push these applications to a server that is continuously listening in for requests from users and applications, and then once it gets that request and with the data, it'll run that data, it'll run the model, and send the output from that model back to that requester. So that needs to be maintained somewhere. That needs to be reliable. That needs to be available 24 hours a day, 7 days a week, and it has to be scalable. So if you have 5 applications pinging that API, and that triples and that doubles and that just starts getting larger and larger, then your service needs to be able to handle that request. It's much easier to build that type of service in a cloud infrastructure type of environment rather than trying to build it on-prem on your own local servers or on your local machine. Talk about being available 24 hours a day. That's not going to happen. So we'll leverage cloud platforms for that quite a bit. Now, for a long time, AWS was the only show in town. They pretty much invented the category, and they've dominated it for a while. They're still the number one player in the space by far, but what's happening now is you have a couple of other folks that are getting in on the game. You have Microsoft Azure, that is now the second ranked player in the space. They're followed by GCP, I believe, Google Cloud Platform, and then you have Alibaba, IBM also in the mix. Why this is great, why this is awesome for us is because more competition is generally a good thing for the consumer, and me being a consumer, I wholeheartedly encourage this competition. So with more competition, I'm going to expect to see a couple of things, and this has materialized in the last year or so, and I'll give you some examples. But one is more AI and machine learning services for data scientists, specifically for data scientists. So for example, on these cloud platforms, as a data scientist, I can utilize high-level APIs. So if I want to leverage Google's image recognition capabilities, they already have a service that's been stood up. They have a model that's been trained, and I can just hit that API and I can get that response and integrate that into my product or my service. Okay, so maybe their image recognition model is too general for me. So, well, I can retrain a version of their model and customize it specifically for my particular use case. So yes, Google's image recognition capabilities are strong, but they're too general. We can retrain them for, say, X-ray images or teasing out the species of one particular animal, something that's very sort of narrow and unique to a particular space. We can retrain that model and still leverage that with not too much more effort. Now, if I wanted to train something completely from scratch, I can also use popular machine learning frameworks like TensorFlow and PyTorch in a GCP environment or an AWS environment and build something from scratch and train that and have that be deployed to a server and have that be serving predictions to my applications. So whatever it is that I need, I'm going to be able to leverage some part of the tech stack for these individual cloud providers. So as they're trying to compete for my business, they're going to come out with better capabilities and more varied capabilities to make my life easier. A great example of this is AWS's re:Invent conference late last year. If you check out the keynote speech, I'll link to it in the description of the video. They spend quite a bit of time talking about how they're expanding their machine learning services and capabilities, and some of the things that they've announced, like the AWS SageMaker Studio, I think that's right. That to me is an amazing innovation. It's going to make collaboration between data scientists much easier. It's going to improve the user experience of data scientists. I'm really eager to kick the tires on that, and that's just an example of this increasing competition and the benefits that they have for data scientists and the end consumers like myself and my clients, for example. All right. I also expect that to drive prices lower. So that's great. The cheaper, the better. If I think about how if you look at the research and think about how expensive it was to train a neural net 5 years ago versus 3 years ago versus 1 year ago versus today, it's just a dramatic drop in cost. And as you see this marketplace develop, I think you're going to continue to see that those prices drive lower, therefore increasing machine learning and AI innovation. So I'm pretty excited about that. So that is theme number 3 for me, the ongoing cloud wars. And I say carry on, folks. All right, trend number 2 for me is AI-themed hardware, or computer chips that are especially optimized for machine learning and AI. So a little bit of background here. Much of AI's recent evolution and innovation has come from improved hardware that have made it easier to run very complicated mathematical computations and also process large amounts of data. So we're seeing specialized hardware in 3 flavors in the AI and machine learning space. One is in specialized chips like GPUs, graphics processing units, and also TPUs, tensor processing units. These make it easier to train very complicated neural net models, for example. And so the better these chips are, the more readily available they are, the better that we're going to be able to train these models and test them and validate them. Area number 2 where you see specialized hardware is in faster inference. So you've already trained your model, now you've pushed that model to production. How do you make it efficient for that server to input all of the data that it needs to input, quickly process that, run it through the model, and then take the output from that model and push it back to the requester or the application. You need specialized hardware to do that, depending on how high of a input that how large of an input is coming into the model, how it needs to be processed, how it needs to be run through the machine learning model. And so what you're seeing companies come out with chips that are specifically optimized to do this inference at scale in a reliable way. So that's pretty cool. Look out for improvements there. The third area in which you're seeing this improve is on the edge. So it's one thing to have a model sitting on a server in the cloud. It's another thing to push that model to a low energy device on the ground and still have that model give you pretty good performance and pretty good predictions. So for example, if you wanted to train a pretty complicated model and have that sit on a drone, for example, you'll want specialized hardware that is optimized to be very efficient within that particular sort of vehicle, and still do the machine learning process that it needs to do. So in these three areas, you're seeing the traditional chip makers like NVIDIA and Intel come out with their own particular flavors of the chips, and you're also seeing a number of startups that are popping up that are just doing these things specifically. So a lot of cool things that are happening here. Again, the better the hardware gets, the better that we're going to be able to train data science models and machine learning models, the better our AI is going to get. So look out for some cool chips and announcements there. All right, everyone, home stretch. The number one trend that I am going to be looking out for in 2020, drum roll please, is going to be advancements towards general AI. All right, so a little bit of background. So general AI is the holy grail for the AI and machine learning industries. So the way to think about this is with the lens of two kind of competing types of AI. You have your narrow AI, and then you have your general AI. Narrow AI is what we're all familiar with. It's been around since the late 1990s, if not earlier. Think of IBM's Deep Blue, which beat Kasparov in chess in the late 1990s. That's an example of general AI. It's a super complicated computer program that beats a human at a very complicated game, chess, yes, for sure. But if you were to take that same program and have it play checkers, it wouldn't do so well. If you would take that same program and try to play some other game, it's not going to do anywhere near as good as in the game it was designed for. And so that's an example of narrow AI. These are applications that only do that one thing that they were designed to do very, very well. And that's great. That's awesome that we're developing applications that are doing more and more complex things. But the next level after that is being able to generalize those applications so that they're not only doing well in the particular narrow field that they've been trained for, but they're also doing well in adjacent functions and fields that are completely different from what it's seen in the past. And so a real big improvement this past year was the announcement that DeepMind's AlphaStar program was able to beat some professional players in StarCraft 2. And StarCraft 2 is a very complicated game. It's an online game. It's a strategy game. It's real time. It's team-based. There's imperfect information. There's game theory going on. So from a complexity perspective, the fact that AlphaStar was able to beat professionals in that space is super cool, and it's impressive. But just as impressive, if not more, is the fact that AlphaStar is also able to play a number of Atari games very, very well. So you're taking the same application and it's doing this game, it's playing this game, StarCraft 2, very well, but then you can turn around and leverage it for other games as well and have it train itself to learn those games without any domain-specific training data, just sort of the rules, some simulation, and a lot of time and a lot of compute to develop strategies to win within those different games. So that's really exciting. To me, general AI is going to be a civilization game changer. When we figure that out, it's going to open up a ton of innovation, and you have a couple of companies that are moving in that direction. I mentioned DeepMind. There's some other companies that are doing some interesting work there. So I am going to be looking out for those headlines and seeing how well they're generalizing to other functions and other news there. All right, so those are the trends that I am going to be tracking in 2020. Leave me a comment. What are you going to be looking forward to in 2020? What did you find particularly cool in 2019? And until next time, keep on hacking, keep on coding, and thank you for tuning in. Talk to you later. Bye-bye.